Part 1. Overview of the Packet Tracer program. The network size is larger than most of the networks you experience in this course. Although you will see this topology often in your networking academic studies, you may need to adjust the window size of Packet Tracer to see the full network. If necessary, you can use the zoom in and out tools to adjust the size of the Packet Tracer window. Step 1. Access the Packet Tracer help page, tutorial with videos, and online resource. A. Access the Packet Tracer help pages in two ways. First, click the question mark icon in the top right hand corner of the menu toolbar. Second, click the help menu and then choose contents. B. Access the Packet Tracer tutorial videos by clicking help tutorials. These videos are a visual demonstration of the information found in the help page and various aspects of the Packet Tracer software program. Before proceeding with this activity, you should gain some familiarity with the Packet Tracer interface and simulation mode. First, view the interface overview video in the Getting Started section of tutorials. Second, view the simulation environment video in the real-time and simulation modes section of tutorials. C. Find the configuring device using the desktop tab tutorial. Watch the first part to answer the following question. What information can you configure in the IP configuration window? So is DHCP or static, and configure the IP address, subnet mask, default gateway, and DNS server. So step 2. Toggle between real-time and simulation modes. A. Find the real-time word in the bottom right corner of the Packet Tracer interface. In real-time mode, your network is always running like a real network, whether you are working on the network or not. Your configurations are done in real time, and the network responds in near real time. B. Click the tab directly behind the real-time tab to switch to simulation mode. In simulation mode, you can watch your network run at a slower pace, observing the pace that data takes and inspecting the data packet in details. In the simulation panel, click Auto Capture or Play. You should now see data packets represented as envelopes of various colors traveling between the device. D. Click Auto Capture or Play again to pause the simulation. E. Click Capture or Forward to step through the simulation. Click the button a few more times to see the effect. F. In the network topology on the left, click one of the envelopes on an intermediate device and investigate what is inside. Over the course of your CCNA studies, you will learn the meaning of most everything inside these envelopes. For now, see if you can answer the following question. Under the OSI model tab, how many in layers and out layers have information? So answer will vary depending on the layer of the device. Under the inbound PDU details and outbound PDU details tabs, what are the headings of the major stage section? Internet at 02.3 LLC SDP BPDU. Next, click back and forth between the inbound PDU details and outbound PDU details tabs. Do you see information changing? If so, what? The source and or destination addresses in the data link layer are changing. Other data may be changing as well depending on which packet the student chooses to open. G. Click the toggle button above simulation in the bottom right corner to return to real-time mode.
Okay, step 3 is toggle between logical and physical views. A is find the logical word in the top left corner of the packet tracer interface. You are currently in the logical workspace where you will spend the majority of your time building, configuring, investigating, and troubleshooting network. The note: although you can add a geographical map as the background image for the logical workspace, it does not usually have any relationship to the actual physical location of devices. B is click the tab below Logical to switch to the physical workspace. The purpose of the physical workspace is it gives a physical dimension to your logical network topology. It gives you a sense of scale and placement, how your network might look in a real environment. And C is during your CCNA studies, you will use this workspace on occasion. For now, just know that it is here and available for you to use. To learn more about the physical workspace, refer to the help files and tutorial videos. Please click the toggle button below Physical in the top right corner to return to the logical workspace.
I want to present part 2, step 1. Identify common components of a network as represented in packet tracer. The icon toolbar at the bottom left-hand corner has various categories of networking components. You should see categories that correspond to intermediary device, end device, and media. The connection category with the lighting board icon represents the networking media supported by packet tracer. There is also an end device category and two categories specific to packet tracer, custom-made device, and multi-user connection. The first question is list the intermediary device categories. The categories are wireless router, multi-layer switch, LAN switch, firewall appliance, and router. Next, without entering into the internet cloud or intranet cloud, how many icons in the topology represent endpoint device? Only one connection leading to them. We can count here in home office 1, 2, 3, 4. In central 5, 6, 7, 8, 9. And the last in branch 10, 11, 12, 13, 14, 15. We got 15 icons in the topology. Without counting the two clouds, how many icons in the topology represent intermediary device? Multiply connection leading to them. We also count at here. In home office 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got 11 icons in the topology. Next, how many intermediate devices are routers? Note, the links device is a router. We got three device router. Next, how many end devices are not desktop computer? A and devices are not in desktop computer. The next question is how many different types of media connection are used in this topology? We use 4 different types of media connection in this topology. The last question is why is not there a connection icon for wireless in the connections category? Because wireless connections are not physically made by the network technician.
Step 2. Explain the purpose of the device. A. In Packet Tracer, the server PT device can act as a server. The desktop and laptop PC cannot act as server. Is that true in the real world? Based on your study so far, explain the client-server model. In the modern network, a host can act as a client, a server, or both. Software installed on the host determines the role in play on the network. Servers are hosts that have software installed that enables them to provide information and service, like email or web page, to other hosts on the network. Clients are hosts that have software installed that enables them to request and display the information obtained from the server. A client could also be configured as a server simply by installing server software. B. List at least two functions of intermediary device. Regenerate the retransmit data signal, maintain information about what pathway exit through the network and inter-network. Notify other device of error and communication failures. Direct data along alternative pathway when there is a link failure. Classify and direct message according to the QAS priorities. Permit and deny the flow of data based on security system. List at least two criteria of choosing a network media type: the distance the media can successfully carry a signal, the environment in which the media is to be installed, the amount of data and the speed at which it must be transmitted, the cost of the media and installation.
Part 3 Part Dual Step 3 Compare and construct LANs and WANs. A. Explain the difference between a LAN and a WAN. Give an example of each. LANs LAN provide access to end user in a small geographical area, and a home office or school campus are example of LANs. WANs provide access to user in a wide geographical area over long distance, spanning a few million of thousands of miles. A metropolitan area network and the internet are example of WANs. A company intranet may also connect multiple remote seats using a WAN. In question B, in the Pocket Tracer network, how many WANs do you see? There are two. And then question C, how many LANs do you see? We can see 3 LANs. And then question D, the internet in the Pocket Tracer network is overly simplified and does not represent the structure and form of the real internet briefly describe the internet. The internet is mostly used when we need to communicate with the resources on other network. The internet is a global mesh of interconnected internetworks. Question E, what are some of the common ways a home user connect to the internet? Cable, DSL and dial-up, cellular and satellite. Question F. What are some common methods that businesses use the network to the interface in your area? Dedicated Lecet line and Metro E, DSL, cable and state line. Challenge. Now that you have had an opportunity to express the network represented in this pocket tracer activity, you may have picked up a few skills that you would like to try out, or may you would like the opportunity to explore this network in more detail. Realizes that most of the what you see and experience in the pocket tracer is currently beyond your skill level. Here are some challenges you may want to attempt. Do not worry if you cannot do them all. You will be a pocket tracer master user and networking designer soon enough. Add an AND device to the topology and connect it to one of the LANs with a media connection. What else? Does this device need to send data to other end user? Can you provide the information? Is there a way to verify that you correctly connect the device? Here you can see the topology of this pocket tracer, and here the connection of LAN and LAN with a media connection, and then the devices. Add a new intermediary device to one of the network and connect it to one of the LANs or WANs with a media connection. What else does the device need to serve as an immediately to another device in the network? So here you can see the topology of pocket tracer that we did, and here we go the challenges of pocket tracer. Thank you.